Hello, this is Mario from ODEON. In this video, we will explain multi-point responses and single-point responses. In ODEON, responses are the full calculations that will yield your final results. The multi-point response is a set of calculations made with your selected sources and all of your receivers individually. This will provide you with the numerical values for acoustic parameters, as well as some bar graphs, spatial decay curves, and statistics curves. Multi-point responses will calculate for all acoustic parameters available in your edition of ODEON, and even in the Basics edition, it will calculate all the parameters you need to comply for the standards for ordinary rooms, open plan offices, workplaces, and speech transmission index. The single-point response is available in the Auditorium and Combined editions of ODEON. It focuses on a single receiver, but provides a whole new set of data exclusive to these two editions. For example, you will get the decay curves, intensity hedgehogs, reflectogram, and a binaural impulse response, which allows you to produce auralizations. In order to calculate responses, first, you need to have defined sources and receivers, and assigned materials to all of your surfaces. These are explained in previous videos of our playlist on getting started. Additionally, you need to have defined an appropriate impulse response length and number of late rays. These are set in the room setup. There are ways to figure out appropriate values for the impulse response length and the number of late rays. However, since that requires looking at some results, we will just use preliminary settings for now. You can click on the Quick Estimate icon to suggest an impulse response length. And you can click on this Engineering button to suggest a modest number of late rays. These settings are explained in more detail in our video on calculation parameters. To save the settings, simply close the window. Then you go to the job list, which is where you perform calculations. Each row in this table is called a job, which can each have a specific calculation setup. At the left side of the screen, you will see a list of your sources. You simply tick the sources you want to be active for the currently selected job. You can toggle all sources on and off with the Alt-Space shortcut. And you can toggle only the highlighted sources on and off with the Ctrl-Space shortcut. Keep in mind that all ticked sources will be active simultaneously during the calculation. Each job can have a different set of active sources, which is one of the main reasons to define various individual jobs. And you can enter descriptions for the jobs. The multi-point response is the basic results you can calculate in every edition of ODEON. The name multi-point refers to the receivers, meaning ODEON will calculate the response at multiple receiver points. By default, this will be all receivers, and you can later select to view only a few specific receivers. To enable a type of response to be calculated, you must tick the checkbox at the top, as well as for each job where you want that type of response to be calculated. So here, I will enable multi-point responses generally, and then also for this job. Then we can click on Run Single Job, which will calculate all enabled responses for the currently selected job. Alternatively, Run All Jobs will calculate the enabled responses for all jobs. This is when it becomes useful to use the checkboxes. For now, I will only calculate the multi-point response for this single job. The calculation has already finished for all 6 receivers. That was quick. A green cell means a specific type of response has been calculated for a specific job, and the results are available to view. We can start taking a look at the selected job's results by clicking on the View Multi-Point Response icon. In this first window, you select which receivers will be active receivers for the results. As previously mentioned, all receivers are selected by default, but you can define different groups of receivers by clicking on a group number, specifying your active receivers, and then clicking on either of these buttons. If you choose to link the group to the job, this group of receivers will be the default whenever you open the multi-point response for this job. You can undo this linking by clicking on the Save and Unlink button, which will reset the default to all receivers. Receiver groups are especially useful for cases like this open plan office, where you can define a group of receivers in a straight line to measure spatial decay and distraction distance. The next tab, Energy Parameters, will display numerical values for your room acoustic parameters. You will notice that each group of results is for a single receiver. For instance, the first results here are for receiver 1. Then you have this table with parameters by rows and octave bands by columns. Below the table, you have broadband parameters. If you use the multi-point response in Edition Auditorium or Combined, you will also get some parameters exclusive to these editions, such as strength, definition, and clarity. You can see which parameters are available in which editions by going to our website odeon.decay, Product, Prices and Editions, and then going into the feature sheet. Specifically, the Auditorium and Combined editions will include all parameters required for ISO 3382 Part 1 for performance places. We will mention some considerations regarding some of the parameters. Here, you will see 2 EDT parameters, one simply called EDT2. Currently, the standard way to calculate EDT is with a linear regression. This is the first EDT you will see in the results. However, the intention of the original inventor of the parameter was to calculate it without a regression. So, the calculation of EDT without a regression will soon be updated in ISO 3382 Part 1. The EDT2 parameter corresponds to EDT calculated without a regression, so it is ready for use for when the standard is updated. Reverberation parameters will only be valid if you had only one active source. Multiple sources should only be used for parameters such as SPL and STI. SPL will only be relevant if you have properly defined the source's power. Here, the source had a power of 31 decibels across all octave bands, so it gives the same results as G. Strength G will only be calculated if there is only one active source, it is a point source, and its directivity file contains Omni in the name. STI will only be relevant if you have defined the correct source power and background noise. In this case, they are not defined, so the results here should not be taken as reliable. For STI calculations, please watch our dedicated tutorial video on STI. Scrolling down, you will then see the same results for the next receivers. Keep in mind that this tab and the rest of the tabs will only show results for your active receivers. Then, the next section will show tables for parameters and receivers by rows. You will find it by scrolling further down or clicking on this button. Other sections are broadband parameters ordered by receiver, statistics for frequency parameters, statistics for broadband parameters, and ISO parameters. After performing a calculation, you can gauge the reliability of your results by looking at certain parameters, such as the Decay parameter, curvature, and the reflection density, or looking out for parameters that could not be calculated. Sometimes you will need to readjust the impulse response length or the number of late rays and perform a new calculation. We explain the appropriate way to do this in our tutorial video for calculation parameters and reliability of results, which is the next video in our playlist for getting started with ODEON. In this window, the Ctrl+C shortcut will copy all the data with tab-separated values, so you can paste it directly into Excel. You can also highlight only the data you want to copy. This tab will show bar graphs for the frequency-dependent parameters. You have frequency in the horizontal axis, parameter value in the vertical axis, and receivers with colors. You can navigate through parameters with the left and right arrows. Graphical results across ODEON, as well as 3D views, can be copy-pasted with the Ctrl+C and Ctrl+V shortcuts, and you can paste them in external software such as Microsoft Office applications. We explain some guidelines on exporting figures in our video on exporting clear figures for reports. Alternatively, you can export the data in graphical results as tables of numbers. To do that, go to this third menu at the top. This is a context-sensitive menu, which changes depending on the currently active window. So currently, it will open a menu corresponding to the energy parameter bars. This menu will show many hidden functions and shortcuts for different windows in ODEON, so we recommend to make a habit of checking it on different windows. Back in the parameter bars, you can export the data with the ASCII output option. Again, the data will be nicely arranged when copied to a spreadsheet. The next tab will show bar graphs for broadband parameters. In this case, we have receivers in the horizontal axis. Again, you can navigate through parameters with the left and right arrows. Next, we have the Parameter versus Distance tab. As the name implies, now you have distance in the horizontal axis, marking the positions for your receivers. The frequency bands are shown with different markers. Certain tabs, like this one, will only be available after meeting certain conditions. For example, this tab is only available if more than one receiver has been defined in the model, there is only one active source, and this source is a point source. You can look at the conditions for each tab by pressing F1, which brings up the context-sensitive help for the current window. Here we have a Statistics tab. This tab will show the averages, minima, maxima, and standard deviations for all currently active receivers. Receivers that were disabled in the first tab will not be included in the statistics. Simulated data will be shown in red. And if you have entered real measured room data, it will also display here in blue. We will show how to add measured data a bit later. The next tab is the spatial decay curves. Here you will see the rate of spatial decay at the top. Also, you can navigate through octave bands with the up and down arrows. Next, we have the STI versus distance tab. The distraction distance and privacy distance will be displayed at the top. Just like before, the conditions to enable these last couple of tabs can be found in the context-sensitive help. If you have more than one active source, you will also see a noise control tab. Here, the individual contributions of different sound sources are displayed. The SPL values will be updated when sources are turned on and off, allowing easy evaluation of their individual contributions. Finally, we have the Simulated versus Measured and Targets tab, where you can compare simulated results against measured results. There are a couple of ways to load the measured data. If you have the parameter values, the data should be arranged in this format. Each block contains data for each receiver position. At the top of each block, you have the word receiver, and then the receiver number in the next cell. Then, each row will have the parameter, followed by the values in octave bands. Here, there are 8 columns for the 8 octave bands from 63 Hz to 8 kHz. To omit information at a specific octave band, you can enter a dash. Then, to enter the data, you should first be in the Simulated versus Measured and Targets tab in the multi-point response. Then go to the Context-Sensitive menu and select Open Edit Measured Data File. Here, you can just directly copy-paste the data from the spreadsheet. Then save and close the window. You can then load the measured data with the Ctrl-R shortcut. Now, each set of measured data will be displayed together with the simulated data for each receiver. If you have the impulse response wave files, you can also load the data through ODEON's measurement system without having to make a spreadsheet. This method is explained in another video. Again, you can navigate through parameters with the left and right arrows, and through octave bands with the up and down arrows. These arrow key shortcuts will typically apply in any window where you can navigate through parameters or octave bands. But here, you can also navigate through receivers with the R and Shift-R shortcuts. So, in this window, you can assess the accuracy of your model in reference to real measured data. If you double-click anywhere on this window, you get a table comparing the numbers for the currently shown parameter. This even shows the differences in just noticeable differences. The value of each parameter's J&D can be edited in Audition's Auditorium and Combined in the Room Acoustics parameter list, which we explain in another video. We can also go back to the Statistics tab and compare simulations versus measurements for the statistics curves as well. If you're working on a new design where the parameters should fall within a target range, you can define target curves in a similar way to how you enter measured data. We will go back to the Context-Sensitive menu. Then we go to Open Edit Target Data File. You can define minimum and maximum values for each parameter, which will again be in octave bands. Here, it might be easier to enter the values directly, and you can separate the values with any number of spaces or tabs, though you can also copy them from a spreadsheet if you prefer. The Compare and Average tool allows you to display the results of various multipoint jobs at the same time, as well as average results between those jobs. You can even compare results from different models. This tool is explained in another video. You can automatically generate a batch of jobs with each of your sources set as the active source. To do that, first select a job, which will also be where the first job will be generated. Then click on this icon. Since each job will have each of your sources as the active source, ODEON will generate as many jobs as the number of sources in your model. ODEON will warn you that the selected job and the ones below will be overwritten. You can then use these jobs for multi-point responses or single-point responses. Now we will talk about the single-point response, which again is available in Audition's Auditorium and Combined. To calculate a single-point response, first enable it here, then select the receiver. Additionally, here you can select the orientation of the receiver. However, this is only relevant for auralization. So, if you are not calculating auralizations, then it is not necessary to specify. With the current job settings, if I click on Run All Jobs, this will only calculate the multi-point response for job 1, the multi-point response for job 2, and the single-point response for job 1. Although the grid response is enabled for jobs 1 and 2, grid responses are not enabled in general. Knowing this, I will click on Run All Jobs. Again, you can tell from the green cells which responses were calculated. Now we will view the single-point response for job 1. We will click on the job, then click on the View Single-Point Response icon. The first two tabs will show bar graphs and numerical values, not too different from a multi-point response for a single receiver. However, you will get some additional results exclusive to the single-point response. For example, the stage support parameters are only available in the energy parameters of the single-point response. For these parameters to show up, the source-receiver distance must be between 0.9 and 1.1 meters. Then you have the decay curves. These curves are for a point-to-point response, so they are different from the decay curves in the global estimate, which are for global decay. On the right side, you can see the intensity hedgehog. The direction of the vectors indicate direction of arrival, the length represents the intensity in decibels, and the colors represent time ranges of arrival. The current color scale is appropriate for music, but you can change the color scale for other applications with Alt-S. For example, there are timescales appropriate for speech or for a studio. Again, remember that you can find all commands and shortcuts in the context-sensitive menu. You can navigate through octave bands with the up and down arrows as usual. And you can also look at broadband curves, either linear weighted or A-weighted. The individual data points in the decay curve are not instantaneous measures of intensity. Rather, they are vector sums of intensity by time slices. You can change the resolution of the time slices with R and Shift-R. For tracing echo events, a resolution of 10 milliseconds is typically appropriate. Notice that I've placed the mouse on the plot. You can zoom into the decay curves by holding left-click and dragging towards the bottom right. The plot will then zoom into the drawn rectangle. The hedgehog will only display the intensity peaks currently shown in the plot. Also, the hedgehog corresponds to the intensity simulated curve, so for now, we will disable the rest. Specifically, the intensity peaks in the hedgehog are the local maxima of the currently displayed intensity simulated curve. So, depending on the reflection density and the time resolution, an intensity peak in the hedgehog could be an individual reflection or a sum of a small group of reflections. If the time resolution is too coarse, you may end up grouping too many reflections into a single peak. If the time resolution is too fine, you may start to see noisy components that don't correspond to actual reflections, so they're not very meaningful. The most appropriate time resolution to use will depend on the specific case. You can navigate through intensity peaks with the P and Shift P shortcuts. If you would like to look at individual peaks in the hedgehog, you can hide the rest of the peaks with the H key. There are other ways to adjust the plot. You can move the graph up and down with the scroll wheel, or drag it in any direction by holding right-click. And you can zoom out by holding left-click and dragging towards the top left. This will always reset the zoom completely, regardless of how large you make your rectangle. These ways to adjust the plot also apply to other curve plots in ODEON. You can navigate through intensity peaks rapidly by holding the P key, and you will also see the red cursor advancing in the decay curve. You can also click directly on intensity peaks in the decay curve. You can collapse the intensity hedgehog view by clicking on this bar at the right side. Then, you will see the decay curves for all octave bands. You can re-enable the intensity hedgehog with the same side button. Now, let's go to the decay roses. Here, you can navigate through octave bands. And there is also a reflection density graph. In the next tab, you will find the Reflectogram. In this graph, the red bar indicates the currently selected octave band, and you can change to other octave bands with the up and down arrows or by clicking on any of the other bars. You can navigate through the reflections in different ways. You can navigate in time with the T and Shift T shortcuts. You can navigate in elevation with the E and Shift E shortcuts. And you can navigate in azimuth with the A and Shift A shortcuts. You can go back to displaying all reflections by pressing F9. Right now, the colors represent ranges of arrival time, but you can have them represent reflection orders instead with the O shortcut. You can change the color for each reflection order by going to Options, Program Setup, User Interface Colors. And you can change the colors here. You can click on the reflections in any of the plots, which will update the 3D view. And you can also click on a reflection in the 3D view, which will indicate it in the Reflectogram. With Alt-T, you can toggle interior and exterior surfaces. But it also allows you to visualize reflection surfaces only. This is useful to pinpoint surfaces causing problematic reflections. Just like in the decay curve, if you zoom in the reflectogram, the 3D view will only display the reflections visible in the reflectogram. In this specific case, we have two symmetrical reflections that are superimposed in time. The maximum reflection order visible in the reflectogram depends on the transition order, which is set in the room setup. So, if you need to visualize higher reflection orders, you can simply increase this parameter. However, this comes with some drawbacks, such as increased calculation times. The next tab is simply a full display for the current 3D view. Next, we have the binaural room impulse response. This tab will only be shown if you have enabled binaural impulse responses in the auralization setup. For a full guide on binaural room impulse responses and auralizations, you can watch our tutorial on auralizations in ODEON. In the next tab, we have the dynamic diffusivity curves. And here we have the ditch echo curves. This plot also shows thresholds for different levels of annoyance. Finally, there is a way to obtain the frequency response curve, which requires the room's impulse response. However, the room impulse response is currently being filtered by a head-related transfer function and a headphone filter. This is done by default for the sake of listening to auralizations. But to get a proper frequency response curve, we will need to disable them in the auralization setup. For the HRTF, we select this Unity file, which is a flat filter. For the headphone filter, we select the first blank option. This way, we will get the room impulse response unaffected by any filters. We close the window to save the settings. And then recalculate the job. In the BRIR tab of the single point response, you can play the impulse response from the context-sensitive menu. Alternatively, you can play it directly by clicking here. Then, in either of the two places, you can save the binaural impulse response, which in this specific case is actually a monaural impulse response. This impulse response can then be loaded into the measurement system by clicking this icon. When loaded, you can go to the Frequency Response tab. Just remember to re-enable the HRTF and the headphone filter if later you want to produce auralizations. If you use Repeat Selected Job for all sources on a job with a selected receiver, this receiver will simply be repeated for all jobs. So, it will generate a list of jobs combining each of your sources with the selected receiver. Also, you can select whether you want the receiver to point towards each of the sources in all generated jobs. Additionally, for single point responses, you can also repeat the selected job for all receivers. Meaning, ODEON will take the active sources in the selected job and generate a list of jobs combining those active sources with each of your receivers individually. There is one more type of response in ODEON, which is the grid response. However, it will be addressed in our video on defining and using color grids. Also remember to watch our video on reliability of results. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!